Hi everybody, I am Asudha, Assistant Professor, Department of Electrical Electronics Engineering in Coimbatore Government Institute of Technology, Vellore. We will be seeing the power system analysis through e-learning. Let us see what is the core objective. The main objective is to model the power system under steady-state operating condition and to understand and apply arbitrary techniques for power system analysis, to model and carry out short circuit studies on our system, and also to model and analyze stability problem in our system. Let us see what we are going to see in the first one is go to your power system. Here we will be seeing about what is the need for system planning and operation studies. We also see about power scenario in India, what are the power system components and how it is represented. We will see the single line diagram for unit quantities, for unit impedance diagram and for unit reactance diagram. We also see about the network graph, bus incidence matrix, primitive parameters, bus admittance matrix from primitive parameters. Representation of off-nominal transformer and formation of bus admittance matrix for larger power network. Introduction. The electrical energy is generated by converting the other forms of energy which is available naturally. The controlling of electrical energy, transmission of energy over a long distance to different long load centers, and distribution and utilization of electrical energy together is called as electrical power system. What is the need of system analysis and planning? Planning is an essential part of any design and implementation process. Before start of new plant, the estimation of needs of localities, that is what is the load required to be serviced by the plant. Proper selection of site, layout and location of control and switchgear etc. has to be planned. Check if the plant needs to be integrated into an overall grid system. Plan for expansion of the plant in future if need arises, and provision has to be made for that. Transmission and distribution line also has to be planned in advance. This can involve transformers, line layout and many other factors. So in short, unless there is a proper planning, no effective and economic system can sustain. Therefore, the planning and operation of our system is must. The power scenario in India. Let us see what is the total installed capacity. From central sector, the total power installed is 93,477 megawatts, which is about 25.2% of total power. From state sector, it is about 1,03,322 megawatt. This is about 27.9% of total power. Apart from this, the private sector, the power which is given from the private is 1,73,549 megawatts, which is 46.9% of total power. So, the total power from central, state and private, the total will be of 3,70,348 megawatt. Let us see from where the powers are being taken and what is the quantity and percentage of From thermal, the power is 2,30,600 megawatt. That is nearly 62.8% of total power. From thermal, what are the distribution it is done is using coal, it is 1,98,525 megawatt. The majority of thermal is by coal, which is of 54.2 percentage. Lignite is 6,610 megawatt, which is about 1.7 percentage. Then comes the gas, which is about 24,955 megawatt. This is about 6.7 percentage of total power. The diesel, which is about 510 megawatt, it is only 0.1 percentage of total power. Apart from this, there is a renewable. Here we will see what is hydro. 45,699 megawatt of power is taken from hydro, which is 12.4 percentage of total power. And from nuclear, it is 6,780 megawatt. This is nearly 1.9 percentage of the total power. And from RES, that is from renewable energy sources, M&RE, it is about 87,269 megawatt of power. That is nearly 23.6 percentage of total power. So this is how the power as on April 2020. That is the total power is 270.270.348 into about 6 megawatt. Let us see what are the components of power system. The main components of power system are generator, transformers, transmission lines, distribution line, load, compensating devices like shunt compensator, series compensator, static VAR compensator. Let us see one by one how to model this power system components. The modeling of generator and synchronous motor. This is the single phase circuit of a generator, which is represented by the EMF generators G, inter-armature resistance RA, reactances XX, and the current is drawn from the armature, that is IG, down towards the outside. Now let us see for the synchronous motor. Here the motor takes the current IM, which is fed to the reactance of XX, armature resistance of RA, and the back EMF of E. Now let us see the other components. This is a modeling of transformer. Transformer, which is the primary and secondary. The resistance of primary and secondary are represented as R1 and R2. Whereas reactants are X1 and X2. This equivalent circuit of transformer is shown which is referred everything to the primary side. Let us have the input voltage as V1, that is a primary voltage V1, and the secondary voltage V2, which is transferred to primary as V2 dash. Let the current flowing from the primary side be I1. I2 dash is the current referred to the primary side. Here, R0 and X0 represent the nodal components, where R01 is the summation of R1 plus R2 dash, where this R2 dash is nothing but the secondary resistance which is transferred to the primary side. R2 dash is nothing but R2 divided by K square. Similarly, the reactance X01 is nothing but X1 plus X2 dash, which is X1 plus X2 by K square. What is this K? K is nothing but your transformer ratio, which is given by the voltage ratio of E2 by E1, our turns ratio of N2 by N1, which is equal to the current ratio of I1 by I2. Now let us see how to model the transmission line. The transmission line can be modeled either with pi type or P-type. The example of pi type is shown here. It consists of a resistance, inductive reactance, capacitive reactance. If it is of P-type, it is shown in this combination. Now comes the modeling of induction motor. Induction motor is nothing but a voltaic transformer. Here, the equivalent circuit is similar to that of the transformer. Since it is a working transformer, we are going to deal with the slip. So, here, the total resistance R is nothing but your stator resistance plus rotor resistance referred to stator side. Similarly, the reactance is nothing but the stator reactance plus the rotor reactance referred to the stator side. Now let us see the single line diagram. In practice, the electrical power system is very complex and the size is unwide. It is very difficult to represent all the components of the system on a single frame. The complexities could be in terms of various types of protective devices, machines such as transformer, motor, generator, etc. and their connections. It can be either star, delta, etc. Hence, in order to avoid this complexity, the purpose of power system analysis, there comes a single phase, simple equivalent circuit, which is nothing but the one line diagram or single line diagram. Hence, the SLD single line diagram is a picture representing of the entire power system from generating end to the consumer end. This is called as the single line diagram. These are the symbols which are frequently used. Now let us see the important symbols. The rotating machine, which is represented in the form of circular, whereas the bus is represented in the shape of this one, and a two-winding transformer, which is represented by the primary and secondary. A delta connection, which is a three-phase, three-wire system, is shown in this symbol. Coming for star connection, three-phase, neutral and grounded. See, there is a neutral is not grounded. It is nothing but a three-phase, three-wire system. Whereas three-phase, four-wire system, where the neutral is grounded is the fourth wire is shown like this. Then, all the lines which are represented as a transmission line in SLD. This is the symbol of the static load. I am showing you the example of a single line diagram of a power system. Here, there are three generating stations G1, G2 and G3. So there are three stations G1, G2 and G3, and this is the bus. There's a number of buses in one. From generating station, it is stepped up by the transformer T1. It is now connection of delta to star, neutral grounded. Then through transmission line, it is connected to the bus. Similarly, the G2, the generated voltage of G2 is stepped up by the transformer and it is transmitted and connected to the bus 1. Like that, in generating station G3, it is again stepped up by using the step up transformer and through transmission line, it is connected to the bus. So this is a simple single line diagram of a power system. With this, let me wind this section and remaining we'll see in the next video. Thank you.